Q6642. If the engine oil temperature and cylinder head temperature gauges have exceeded their normal operating range, you may have been A. Operating with a mixture set too rich. B. Using fuel that has a higher than specified fuel rating. C. Operating with much power and with the mixture set too lean. The correct answer is C. Engine temperature indicators. The engine oil temperature and cylinder head temperature gauges are essential instruments that provide information about the temperature levels of critical engine components. Monitoring these temperatures is crucial to ensure the engine operates within safe limits. Operating with too much power. When an aircraft is operated with excessive power, it puts a greater load on the engine and can result in increased temperatures. Higher power settings can lead to increased combustion temperatures and heat generation within the engine, causing the temperature gauges to exceed their normal range. Mixture set too lean. The air-fuel mixture in the engine plays a significant role in maintaining optimal operating temperatures. If the mixture is set too lean, meaning there is insufficient fuel compared to the amount of air, it can result in higher combustion temperatures. Lean mixtures burn hotter and can lead to elevated cylinder head temperatures. Effects on temperatures. Operating with too much power and a lean mixture can cause the engine to run hotter than normal. The increased combustion temperatures can elevate the cylinder head temperature, and the excess heat can be transferred to the engine oil, raising the oil temperature as well. This is reflected in the readings of the respective gauges. Risks and considerations. Exceeding the normal operating range of engine oil and cylinder head temperatures is a cause for concern. It can lead to accelerated wear and potential damage to engine components, including pistons, valves, and bearings. Continued operation in such conditions can increase the risk of engine overheating and potential engine failure. 7293. What action can a pilot take to aid in cooling an engine that is overheating during a climb? A. Reduce rate of climb and increase airspeed. B. Reduce climb speed and increase RPM. C. Increase climb speed and increase RPM. The correct answer is A. By reducing the rate of climb, the pilot decreases the workload on the engine. Climbing requires the engine to generate more power, which in turn produces more heat. By reducing the rate of climb, the engine's workload is lessened, resulting in reduced heat generation. Increasing airspeed has a cooling effect on the engine. When the aircraft moves faster through the air, more air flows over the engine, enhancing the cooling process. The increased airflow helps dissipate heat from the engine components, such as the cylinders, oil system, and cooling fins. By combining these two actions, the pilot can effectively aid in cooling an overheating engine during a climb. The reduced rate of climb decreases the engine's workload, while the increased airspeed enhances the cooling process by increasing airflow. This allows the engine to operate within safe temperature limits, preventing potential damage caused by overheating. It's important for pilots to monitor engine temperatures closely and take appropriate actions to prevent overheating. Failure to address an overheating engine promptly can lead to engine damage or failure, jeopardizing the safety of the aircraft and its occupants. 7299. What should be the first action after starting an aircraft engine? A. Adjust for proper RPM and check for desired indications on the engine gauges. B. Place the magneto or ignition switch momentarily in the OFF position to check for proper grounding. C. Test each brake and the parking brake. The correct answer is A. Adjust for proper RPM. Each aircraft has a specified RPM range within which the engine should be operated. After starting the engine, the pilot needs to adjust the throttle or power lever to set the RPM within the manufacturer's recommended range for idle or initial operation. This ensures that the engine is running at the appropriate speed for a smooth and controlled operation. Check for desired indications on the engine gauges. Modern aircraft are equipped with various engine gauges and instruments that provide crucial information about the engine's performance. These gauges may include indicators for oil pressure, oil temperature, cylinder head temperature, CHT, exhaust gas temperature, EGT, fuel flow, and other relevant parameters. By checking these gauges, the pilot can verify that the engine is operating within the normal range and that all indications are as expected. Any abnormal readings or indications outside the desired parameters can be an early sign of a potential issue or malfunction, allowing the pilot to take appropriate actions before proceeding with the flight. By adjusting for proper RPM and checking the engine gauges after starting the aircraft engine, the pilot ensures that the engine is running at the correct speed and that all indications are within the expected range. This initial check is crucial to identify any anomalies or malfunctions early on and take the necessary steps to address them before the aircraft takes off. It is an essential part of the pre-flight procedure to ensure the safety and optimal performance of the aircraft. 7306. An abnormally high engine oil temperature indication may be caused by A. Operating with a too high viscosity oil. B. The oil level being too low. C. Operating with an excessively rich mixture. The correct answer is B. Proper oil level. Engine oil plays a vital role in lubricating and cooling the moving parts of an aircraft engine. Maintaining the correct oil level is crucial for optimal engine performance and temperature regulation. If the oil level is too low, there may not be enough oil to adequately lubricate and cool the engine components, leading to increased friction and heat generation. Cooling effect of oil. Engine oil helps dissipate heat from various engine parts, including the cylinders, pistons, and bearings. It absorbs heat from these components and carries it away, promoting cooling. When the oil level is low, the amount of oil available for heat absorption and dissipation is reduced, leading to an increase in engine oil temperature. Temperature indication. Aircraft engines are equipped with oil temperature gauges that provide real-time indications of the oil temperature. If the oil level is too low, the reduced cooling capacity can cause the oil temperature to rise above normal operating limits. An abnormally high oil temperature indication is a warning sign that the oil level needs to be checked and replenished to prevent potential engine damage or failure. By maintaining the proper oil level, pilots ensure that there is an adequate amount of oil available for lubrication and cooling. This helps regulate the engine's temperature and prevents overheating. Regular oil level checks and timely replenishment are essential for the safe and efficient operation of the aircraft engine. 7307. For internal cooling, air-cooled engines are especially dependent on A. A properly functioning thermostat. B. Air flowing over the exhaust manifold. C. The circulation of lubricating oil. The correct answer is C. Lubrication. Air-cooled engines rely on a constant supply of lubricating oil to reduce friction and heat generation between moving parts. The oil forms a protective film between components, preventing metal-to-metal contact and reducing wear. Proper lubrication is crucial for maintaining optimal engine performance and temperature control. Heat transfer. As the engine operates, heat is generated due to friction and combustion. The lubricating oil absorbs a significant amount of this heat from engine components, including cylinders, pistons, and crankshaft. The oil carries the absorbed heat away from these parts and dissipates it through external cooling fins or an oil cooler. This heat transfer process helps to regulate the engine's temperature and prevent overheating. Oil circulation. The circulation of lubricating oil is essential in an air-cooled engine to ensure that heat is effectively transferred away from critical components. The oil pump circulates the oil through various passages and galleries within the engine, delivering it to areas that require lubrication and cooling. The oil's flow and distribution ensure that heat is evenly absorbed and carried away, maintaining proper engine temperature. By ensuring the circulation of lubricating oil in an air-cooled engine, pilots help maintain the cooling efficiency of the engine. The oil absorbs heat from engine components and carries it away, preventing excessive temperatures that could lead to engine damage. Regular monitoring of oil levels, quality, and proper maintenance of the oil circulation system are crucial for the safe and effective operation of air-cooled engines.